And again, this lecture is not over yet, but I want you to know that this is what we're going to apply for many lectures to come, the decomposition of a complicated trajectory into two simple ones. Now when you look at this, there is something quite remarkable. And the remarkable thing is that the velocity in the x direction throughout this whole trajectory, if there is no air drag, if there is no friction, is not changing. It's only the velocity in the y direction that is changing. It means if I throw up this golf ball, I throw it up like this, and it has a certain component in x direction, a certain velocity. If I move myself with exactly that same velocity, with exactly the same horizontal velocity, I could catch the ball here. It would have to come back exactly in my hands. That is because there is only an acceleration in the y direction, but the motion in the y direction is completely independent of the x direction. The x direction doesn't even know what's going on in the y direction. In the x direction, if I throw an object like this, the x direction simply, very boringly, moves with a constant velocity. There is no time dependence. And the y direction on its own does its own thing. It goes up, comes to a halt, and it stops. And of course, the actual motion is the sum, the superposition of the two. We have tried to find a way to demonstrate this quite bizarre behavior, which is not so intuitive, that the x direction really lives a life of its own. And the way we want to do that is as follows. We have here a golf ball, a gun. We can shoot up the golf ball. And we do that in such a way that the golf ball, if we do it correctly, exactly comes back here. That's not easy. That takes hours and hours of adjustment. The golf ball goes up and comes back here. Not here, not here, not there. That's easy. You can shoot it up a little at an angle and the golf ball will come back here. Once we have achieved that the golf ball will come back there, then I'm going to give this car a push. And the moment that it passes through this switch, the golf ball will fire. So the golf ball will go straight up, as seen from the car. But it has a horizontal velocity, which is exactly the same horizontal velocity as the car. So the car are like my hands. As the golf ball goes like this, the car stays always exactly under the golf ball. Always exactly under the golf ball. And if all works well, the ball ends up exactly on the car again. Let me first show you, otherwise if that doesn't work, of course it's all over, that if we shoot the ball straight up, that it comes back here. If it doesn't do that, I don't even have to try this more complicated experiment. So here's the golf ball. I'm going to fire the gun now. Close. Close. Reasonably close. Well, since it's only reasonably close, perhaps perhaps it would help if we give it a little bit of leeway. There goes the gun. Here comes the ball. And this is just in case. Tape it down. So as I'm going to push this now, give it a push, the gun will be triggered when the middle of the car is here. You've seen how high that ball goes, so that ball will go. And depending upon how hard I push it, they may meet here or they may meet there. You ready for this? You ready? I'm ready. Physics works. See you Wednesday.